So, hi all. Thank you for coming. My name is Vojin Jovanovic, and I'm working as a researcher at Oracle Labs in the VM research group, working on the project called GraalVM. And what I'm going to talk today about is how we do multilingual processing with GraalVM. So if you look at the program on the right, this is taken from the, this is a typical MySQL stored program. You will see like a language not many speak today. It's basically a stored procedure which is used to process data right next where it's located in a database server. And if you look at this program, there is a couple of problems with it. This is basically the only way, for example, in MySQL to write stored programs. And it's essentially a very unfamiliar programming language. So it doesn't have an ecosystem. You don't have Stack Overflow answers as you would have for other languages like JavaScript. It has a very few available libraries. It doesn't even have libraries. You have to copy-paste code in order to put it into the database. And then it has very poor development tools. So you will not get a debugger, and the IDEs will be questionable. On top of that, this is a language developed only for MySQL. So it runs basically in a single database. If you want to change your engine because MySQL doesn't fit your needs anymore, you can't do that if you write programs like this. And then finally, it's a very small kind of implementation, so performance is very limited. So this is interpreted in an interpreted language, so you will never get something you would get from Java or JavaScript. And then further, in other processing engines, like Spark, for example, you will have other languages. But then, like Python and R, and in Postgres, there are extensions that add Python and JS. But in these processing engines, you will essentially have a performance penalty. And the reason is that each one of every implementation, so Spark has Spark Python, Spark R, Spark JS, Postgres has PLV8 and Python. So they're basically, every implementation is relying on a specific runtime. And then this usually involves expensive calls which often go across the process boundary. So you need some sort of data serialization and deserialization, and that's expensive. So you get the performance penalty, and then you get like a management overhead, because if you have multiple runtimes, then you have multiple heaps, multiple GCs, bugs, and so on. So this is a big problem. So with GraalVM, what we try to do, we essentially build one VM on top of which we implement different languages. And the reason we can do that is because of this layer which is called Truffle, and it does automatic transformation of interpreters to compilers. So what it does is essentially we just implement a language as an interpreter, and you get basically a fast implementation for free. So, and in Graal, what we've done is we provided implementations for languages that are very well used, like JavaScript, Ruby, R, Python. Then we have an LLVM implementation, so we support all of the C and C++ languages, which has an extra benefit of running native code in your database without worrying of your database crashing. And of course, Java. And then through GraalVM, we provide two basically execution modes. One is in a managed application through a hotspot VM, so we will run in OpenJDK, or as a shared library, which we do basically in a database, for example, in an Oracle database and in MySQL, which I'll show today, or as a standalone application. So you can just take your Java application and build an image and run it natively, and many platforms to come. Okay. So, and when you look at all these languages, they're basically of different completeness levels, but most of the languages that we present, there is many in the works as well. But the languages we present are basically usually very well suited for use, especially JavaScript. If you look, for example, at the compatibility with the ECMAScript 2018, you will see that it's essentially even better than the Node.js, right? So kind of you can take a JavaScript program and you can be sure it runs. As a matter of fact, I never hit the JavaScript bug by now while working on it. And then for Ruby, we have similar for the Ruby language. And then because of we build one compiler for all the languages, first of all, some languages don't even have JIT compilers, so we will get way better performance for them. So if you look at R, which doesn't have a JIT compiler, for example, it will be running like in the red. You have R running on GraalVM, and basically, and on the right you have GNU R. You will see it's 4.5 times faster over a range of benchmarks, a big range of benchmarks. So for Ruby, the same thing. And then for JavaScript, we are basically in the same ballpark in the V8 because JavaScript has a handcrafted JIT compiler. But this gap is basically mostly due to regular expressions, which are anyhow easy to fix. So basically same ballpark. So you get reliable languages which are faster or equal to what exists out there. And then in order to put them into different languages, what we do, into different processing frameworks, we provide APIs for embedding these languages. So for example, if you have a Java virtual machine, like something like Spark, you can use this API on the left, which is the JVM API. And if you look at the API, it's very easy to use. Basically, you say create a context. Context is basically just all the data of the program, including the functions. And then you say evaluate in a language JS, and then you do a function. You just do the answer. You say fits in int. So when we execute the function, we say, does this fit in int? And this is essentially, this API is a bit different than what you would find in a typical, for example, V8's API, because you don't know which language is on the other side. So you kind of need to coerce the types properly to what you have. So you ask, does it fit in int? And if it fits in int, you basically convert it. And then we essentially, through our tool native image, we provide the same API just for C. So whether you have a Java processing engine such as Spark, or you have a C processing engine such as PostgreSQL or MySQL, you can basically embed Graal, right, and run all of the languages. So, and I will focus on native projects in this concrete talk because this is our example that just shows how this is done. So in native projects, what we do, but all the principles basically will apply to the hosted version, which is running on the JVM. So what we provide is basically this library called libpolyglot. This library inside contains all of the languages and the given API, this embedders API. And then it has essentially unified interface for all the languages. So you won't say is int because some languages don't have ints, but you will say fits in int, so you can convert it, and then it works for Python, JavaScript, Java alike. And then what you get as well is all the tooling. So you can do debugging and profiling, sampling, memory boxing, name it. So it's basically you have the whole tooling support, and it's also extensible. So if you need better performance somewhere, you can also kind of hand tune a few functions that you need, where you need constantly to cross the boundary between the VM and your project. So, and then as an example, I'll just show what we've done. I'll just show what we've done in MySQL 8. This was a project we did with the team there, and it's essentially just developed a language plugin which kind of wraps around this libpolyglot and gives it SQL-like features. So we just, functions and procedures all of a sudden can become JavaScript functions or Python functions, and we just eval them just as we've seen in the example before. And then we take the result types and we kind of feed them into MySQL. So there is a bit of code, but it's actually quite simple. I wouldn't say most of the work was like not related to the API, but fitting it into MySQL and the parser and whatnot, right? But it's essentially the code that is required is quite simple. And then what you get is essentially, once we do this task, which was not so hard, you're able to run any language that will ever run on GraalVM in MySQL. So if tomorrow on GraalVM we do CLR, well, CLR in MySQL, right? So it's kind of it's a nice investment. So if you would compare it to V8, if you implement it within V8 API, you would just get JavaScript and that's all. If you do it with a Graal API, you get basically all the languages that will be supported. So let's see how this works in MySQL. So what I'm going to run here is essentially a simple hello world. So what we do is we see a similar syntax like to what we have in MySQL is like create function hello.js world, and then here we just return a string. Okay. So let's try it out. Then later we will just select it to see that it's just like any regular stored program. So, okay, created the function. We see if we select it from the routines, we will see hello world.js. Okay.
I think we see something different.
Okay. So we'll have to end show and come back. Sorry for that. This works? Okay. So what we do here again. So what I evaluated just in the MySQL database is essentially this create function hello.js world, which will basically just, you write JavaScript code. You have to delimit it, of course. As you can see here, you have to delimit it compared to to kind of save it from the rest of the parser. But basically, what we do is you just define a function, and then we can treat it just like any other program. So we can select from a table, and you will see that essentially, if you say select routine name, you will get hello.js world. It's a JS routine. It also has the code stored in the database, and then you can, of course, evaluate it, right? So you can do this. So now this is just like a regular stored program. It's just running in Graal. Okay. So now if we push this a bit further, let's take this to an example which is kind of a bit more interesting, and let's take the Levenshtein distance, which is used for string similarity. So this is something that when you go online and say, how do I do this in MySQL, you basically hit a series of blog posts where people say, I tried this, works for me, and like it's slow, and so on. So when you when you go to the JS community, you will of course find it done many times. So I took one of these implementations, and basically I have here a table of 5,000 emails. So essentially, and also because it's JavaScript, you can use all the fancy features like matrices, because it's a dynamic programming problem. So you can use dynamic programming and so on. So what we'll do here is we'll just evaluate the query, and then if you look at the select Levenshtein from all the emails, I have 5,000 emails. We will basically get it done in 1.3 seconds, and that's just the first run. Because it has a JIT compiler, it will warm up over the time, so you will be able to kind of get this query done fairly fast. Okay, and now if try to do the same thing with the SQL implementations, first of all, it's way longer, and then it's way more complicated to do. So I managed to find this somewhere. You will see basically, it also took me like 4 tries to find the correct version online. So if you do this, well, I will get back to my presentation. Can you see the show? Good. Wonderful. Okay, so now we've seen how it works for basically simple stored programs. Let's take a look at the model. JavaScript itself is not much without the ecosystem, right? So you go on npm and you can basically get whatever you want. So what we kind of developed together with this is essentially a tool called db.js, which will, for a program that you would typically run on a client where you use node modules and so on, it will pack it in, ship it to the database, and essentially using Webpack, and it will provide all the functions that you define. So with this kind of a program, you will basically you're able to kind of take your client application and just move it to the database. So let's see this in practice. I have an example, because Levenstein you can still find online, but there are some things you can't really find online, and that's email validation, which is supposed to be very simple, but it's actually not. So if you look at the email validator, what I did here is I took this package called validator, I import it from NPM, and then what we just do is give it a type signature, because it's an untyped function. Ah, sorry. This is annoying. Good. So we have an validator function, which is just, we gave it a type, basically. So we say, is email typed? It's input string, and it returns a boolean. Okay? And then we just export it. So, and now with this tool db.js, we can essentially say just deploy validator or any part of your application that can be packed and send it to the database. So when we do that, so now if you go to MySQL, we can say select email from emails. I have 5,000 emails, out of which some are incorrect, and that's very hard to validate. So from emails, and then we just call this function, which we just picked up off the web. So and then we are, yeah, old language. Good. And then we see it's done in 90 seconds. And this is something you can really not do without going to MySQL, to JavaScript and picking up the modules. So let's go back to the presentation. Here we are. And then we also developed this module called MLE, which allows people to kind of take the libraries, like the MySQL connector library, and essentially with this module you can essentially ask a question: am I in the MLE environment? So on the left side you will see MLE enabled, and then you can do a slightly bit different part of the code. So with this module, what we can do is essentially we can just run any MySQL kind of connector code. So you can make a stored procedure, and this stored procedure will essentially just execute in the server, not going through the network, saving all the round trips. Right? So I cannot demo that because it's a short talk. And then, of course, you get all the debugging. So at any point in time, you can connect with the Chrome debugger, and you can debug any language you basically want. So your database all of a sudden becomes open and easy to kind of find problems in. Okay, so let's just show the Polyglot part. Good. So let's just show the Polyglot part. So now, essentially, if we look at the same implementation, so there is no changes for a language, we can look at this program, which will say, take a string in JavaScript and append JavaScript comment to it. It will take a string in Ruby. This is a Ruby syntax. Take a string then in Python, append Python, and then essentially concatenate the MySQL with all of the functions together. Right? So if you take this query, we can see that all of the languages work together in the same VM. Okay. Of course, you can run more complicated examples as well. So essentially, what I wanted to say, like with this, to give a message essentially, that if you have a data processing engine that you want to make open and easy to use and fast at the same time, GraalVM is basically the way to go. Because you will get essentially fast and portable data processing without vendor lock-in. And we have people, we have us and others working on a version for Spark, for MySQL, for the Oracle database. There will be a talk about that today by Lucas Brown and Julia, and essentially and Postgres. So yeah, so that's all. Thank you very much. GraalVM, if you want to check it out, stay tuned. There is a website and a GitHub repository which is buzzing these days, and of course the mailing list. Thank you very much.